Dear students, today we are going to see matrix description of a convolutional coder. So here you will be having a generator matrix GP whose individual elements G11P, G12P will range up to G1 and P first row, and similarly the last element will be G, K, Kn because we are having K inputs and N outputs. Similarly, the message polynomial can also be represented in the form of matrix, and the output VP can also be represented in the form of matrix. Let us take one example. So here you can see one convolutional coder of rate 1 by 2. Here we are having one input and two output. Now how to write the message polynomial? Let us take one example that message, if message is 101, we will write it as 1 plus p square because a message is of 1 bit. So the matrix size will be 1 cross 1, and we are writing the polynomial 1 plus p square in this particular matrix. Now coming to the generator polynomial GP. So as we are having number of input as 1 and number of output as 2, so the size of generator polynomial matrix will be 1 cross 2. So it will have two elements G11P and G12P. Now G11P means the connection of first output with first input. So you can see that the first output V1 is generated with the help of due to M0 and M2. So M0 and M2, this connection can be written as 1 plus P square. Similarly, V2 is generated by the XOR operation of M0, M1, M2. So we will write it as 1 plus P square. Therefore, the generator polynomial GP, you can see this matrix is 1 plus p square and 1 plus p square. Now to generate the code word, we know that we are having the formula MP into GP. So output, we know we are having two outputs, so we will have V1P and V2P. Now this is the matrix multiplication, and we have to multiply the individual polynomials, and you can see that by multiplying this 1 plus p square with 1 plus p square, we get 1 plus p to the power 4, and multiplying 1 plus p square with the second polynomial, we will get this value, and we are writing it as in the form of bits, and combining v1 v2 we get this final output. Now let us take one more complicated, little bit more complicated example. So here you can see that there are two inputs and three outputs. Now to write the generator polynomial, what we have to consider? We have to consider each of the connection. First input, second output, first input, first output, first input, second output, and first input, third output. So we will write it individually. Now first input and first output. So you can see that the output V1 is generated because of the connection of M0 and M1 of the first input. Therefore, we will write its polynomial as 1 plus p. Similarly, first input and second output. So how the first input is constituting V2? So just check this adder, second adder. So M1 and M0 both are connected to this V2. So again its polynomial will be 1 plus p. Similarly, 1 3 means first input and third output. So in the third adder, the first input bit is generating because M0 and M1 both are connected to this V3 also. So again it will have polynomial as 1 plus p. Now coming to 2 1. So second input, first output. So what we have to observe? We have to observe that from the second input, which are the memory elements which are connected to the first output V1. So what you can see, so see I have written over this line as 2 1. Just take care of it. So only M1 is connected to V1. So since M1 is connected, so we will write it as P. Now in the similar manner, G22, second input, second output. Just check out the line over which I have written 2 2. So you can see that only M0 is connected to the second adder. So we write it as 1. In the same manner, I have written all the other polynomials. And finally, GP will be of 2 rows and 3 columns. GP will be of 2 rows and 3 columns. Now let us suppose we are having input bit stream as 101101000. So same as we are having 2 inputs, so first bit will go to the first input and second bit go to the second input, then again third bit will go to first input and fourth bit will go to second input, in this manner we will segregate them in 2 bit streams M1 and M2 and represent them in the polynomial as 1 plus p and p plus p square, and so the message polynomial will be of 1 cross 2 because we are having 2 inputs. Now Vp is nothing but Mp into Gp. Okay, so what we have seen that our GP is of the size k cross n, so k is of 2 bit and n is of 3 bits, so 2 cross 3, and MP is of 1 cross 2. So final matrix Vp, which is due to the multiplication of MP into GP, will be of the size 1 cross 3. So first row, first column, like this you have to multiply. We all know matrix multiplication very well, and this is what I have shown it here. So first row, first element, first row, second element, first row, third element, and after simplifying it you will get these 3 values which again can be represented in the bit form like this: V1, V2, V3, and when we combine these 3 bits we will get this answer. I hope you have understood. Thank you.